Okay, we're going to do some examples of computing derivatives at points and finding tangent lines here. So let's do a tangent line first. So we're going to find the tangent line to say f of x equals 1 over x at x equals 3. So um, to do this, we're going to use the limit definition of derivative. So I'm going to take the limit as h goes to 0. And I'm going to take f of 3 plus h minus f of 3. So 1 over 3 plus h and 1 over 3 divided by h. We're going to do some algebra. I'm going to multiply everything by 3 plus h times 3 to clear denominators. And we're going to get, well, we'll multiply everything by h too. So, well, the algebra turns this into 3 minus 3 plus h over h times 3 times 3 plus h. Okay, and we get to cancel some stuff. This equals minus h on top. I've got an h on the bottom, I've got a 3 down there, and I've got a 3 plus h down there. The h and the minus h turn into a minus 1. And so when I plug in 0, I end up with just the 3 and the 3 on the denominator and a minus sign on top, so minus 1/9. So the slope, this is f prime at 3. And so that's the slope of my tangent line. So to have a line, I need a direction and a position, or a slope and a point. I've got my slope. I can get a point on the function by plugging in 3 and getting 1/3 out. So I've got a point on the function at 3 1/3, and I've got a slope of 1/9 with a minus sign on it, right? So my tangent line is the line with that slope through that point. So the line, I'm going to have y minus y1 equals m times x minus x1. So this is going to be y minus 1/3 equals minus 1/9 times x minus 3. And if I want to write this as y equals mx plus b, we do a little arithmetic. I get y equals minus 1/9 x plus 1/3 minus plus another 1/3, right? So I get a y equals minus 1/9 x plus 2/3. And if I plug 3 in, I should get a 1/9 out. So, oh, sorry, a 1/3 out. If I plug in 3, that's a minus 1/3. 2/3 minus 1/3 is a 1/3. So yeah, that works out for me. So there's my tangent line. Okay, so we use the derivative to get the slope. We use the function itself to get the point. And then using that, we can find the equation for the line through that point. Let's do another example of finding a derivative. Let's do find f prime at say 2 if f of x equals the square root of x. Okay, so I'm going to take the limit as h goes to 0 of the square root of 2 plus h minus the square root of 2 over h. This is f of x plus h, and I'm evaluating it 2, so I put a 2 in there. This is f of x, so I put a 2 in there. The h always goes in the bottom. Okay, so now I have to rationalize my numerator, right, to find this limit. So this is the limit h to 0. I'm going to multiply by the conjugate, basically. So I'm going to end up with 2 plus h minus 2 over h times the square root of 2 plus h plus the square root of 2. Right, that's my conjugate. Difference of squares on top, multiplied by the positive sum on the bottom. The h's cancel, the 2's cancel, the h cancels there. I'm left with the limit as h goes to 0 of 1 over the square root of 2 plus h plus the square root of 2. So this is equal to 1 over 2 square roots of 2. So that's the derivative of the square root of 2. Or sorry, that's the derivative of the square root function at 2. Okay, that's basically how you do your derivatives. You plug in the right limit and then you take the limit. We've done a lot of taking limits. And I think we'll be pretty good with this stuff. I'll see you guys on Monday.